Okay, welcome everybody to this Cloud Native Asturias June 21 event. Thank you everybody for coming along. Today we have a great agenda. This is the mid-season finale of Cloud Native Asturias for this year. Angel, how are you doing?
I'm pretty good, thanks. Welcome everybody. Welcome, Jose. Thanks for being with us. It's a pleasure. We are looking forward to your talk and to Jesus' talk that will be joining us in a few minutes.
Exactly. Jesus right now is crossing around the Eiffel Tower, actually, so he will join very soon. But that's okay. So yes, as usual, we want to share with you our motto, our mission. We pretend to elevate the student technological landscape through the worldwide collaboration. Okay, we are an official Cloud Native Foundation community group. Okay, that represents at the end the region of Asturias in Spain. In the same way, we have a code of conduct. Okay, you can go to that link, and you will see it. Nothing weird. Just be respectful with each other, with all the people in this event, and that's mainly it. Okay. So as usual, we have this kind of recurrency to put the Asturias in the map. So today, one of the speakers, Jose Redondo, is coming actually from the school, the computer engineering school that we have in Asturias. So I just put the dot over there. You can find more information in the internet. And coming today from France, actually from Paris, we have Jesus. If you can see here that by car is kind of a ride, like 11 hours. You have to put in the measure the stops to get rest. And we have a plane. I think we have a plane. Not sure if direct, but for sure through Madrid. So that's okay. So yeah, you can follow us on social media. These are the hashtags that we are using today. And let's start with important parts. So we will have the first session entitled Docker Strong Foundations for Verifiable Secure Deployments. And after that, we'll have advanced analysis of container security. So you can see, guys and girls, that today we have a very focused subject about Docker and security. I think it's going to be really fun. And our first speaker is Jose Manuel Redondo, which is currently working at the School of Computer Science Engineering, Computing Oviedo in the Twitter, as a professor, let's say higher in the
associate professor.
Associate professor, thank you very much.
Yeah.
And a part of that does research in programming languages, as you can see here. Okay. And after that, we'll have Jesus Escolar. He's a CEO of EXELERYS company, an American startup mainly focused on cybersecurity threats in the internet. Also, you can see here that he's collaborating in a huge amount of initiatives. For example, other brothers like CNCF community group from Paris, from London, and many other events that he's collaborating. What else? Of course, as usual, we will open the Q&A session. You can see in your screen that in the right side, you have several tabs, chat, the general. You can even put there your questions if you want, and the Q&A section specifically for your questions and answers, okay? Last slide, and we pass. Call for papers. People, if you are interested to participate, to be a speaker in this kind of monthly events, please just fill that form that we have there. You can scan the QR code as well, and it will drive you to our form. Being said, I will stop sharing, and I will let the stage to my beloved Jesus Redondo. Jesus Redondo, all yours.
Let's see.
Jesus Jose, más bien.
Don't worry. Students call me worse things. Well, are you actually able to see my presentation?
Yes, there you are.
Okay. Well, then I will start. I mean, I will start humble because I start from a humble position. I am just an associate professor on a university, and my task is to show my students who has no previous knowledge how to secure deployments, okay? And in this case, well, I use the same philosophy for a couple of products, but I will put an example of this philosophy in Docker, okay? Because, well, it's one of the things that I secure this way. So the thing is, I have students that have little knowledge about security, and most of them have even problems to distinguish one valid IP from another. And I have to train the students to be actually able to deploy secure products whenever they want to host the software they are supposed to develop, because we are in a computer engineering degree. So the philosophy that I follow is the one that I am trying to show to you now, because I think that it allows anyone with enough time and patience to start from zero to hero, okay? It allows you to achieve a very high amount of security, and it is not something that I can assure, because it is verifiable and for third-party entities and companies that revise the stuff that they use to deploy secure products, and in this case, Docker, okay? So, of course, my students are not trained, and it doesn't imagine at the beginning that vulnerabilities are discovered daily, and some of them you just cannot be prevented, because, well, you can be a victim of a 0-day or a supply chain attacks that are disgracefully popular today. But in the end, those two things are, well, you cannot really prevent all of them, but you can try to configure your infrastructure, your products, your operating systems, your firewalls, your browsers, your servers as best as you could in an attempt to minimize or mitigate the effect of an error like this. And of course, all the other vulnerabilities that you might face, like misconfigurations or just allowing to authenticate users that doesn't have to authenticate in certain parts. All this stuff can be covered if you know how to do that, even if you start with little infrastructure knowledge at the beginning, okay? So my approach to my subjects dealing with security and administration is called security first. I put security first, and later on, I might consider other things, okay? But first is security. What is the first problem that I have to face? The first problem is that my students usually look for answers in non-trustable media. For example, Stack Overflow, YouTube tutorials, Medium, how to force. They actually tend to use that because I think they are like used to do that when they code. But when you are trying to deploy a secure configuration or a secure product, you cannot rely on that because they are not complete, and of course they are not accurate. They might have mistakes. They might not be updated to the latest standard, but, well, I mean, or they might be a lie, because there are people that actually don't have actual knowledge about how to properly secure things and just develop a tutorial that if you follow it, you become with a wrong configuration or an incomplete configuration, okay? So my first goal is to prevent my students to be tempted by the devil. And the devil is Medium, YouTube, how to force, and those kind of tutorials. I say, don't look to them. I will provide you with a complete, verifiable, maintainable, and very, very thorough source of security controls that you can follow to develop a real deployment of a secure product. And that can be applied to Docker, that can be applied to Firefox, to any operating system, Windows, Linux, to web servers, and to many, many other products, because, for example, the brand of security controls that I use covers over 100 different popular products. So this philosophy can be extended to any of them, and you only have to know where to look and how does that thing work. And the good part is not only that if you invest enough into following these kind of things, you end with a very strongly secure product. The thing is that you also learn, because these products or these guides of security controls also teach you why have you to do some things with the product, even if you don't know at the beginning, because you are no expert. Okay, I will try to show you why I say that. So it's like a recipe. I always explain that to my students, like in the recipe metaphor. What do you need to make a good meal, a good recipe? I will provide you the best recipe that I know of, okay? There are a couple of sources, but I prefer to use one of them. I talk about them, but in the end, I only use one of them, which is the most teaching friendly and is very complete. And you also need reasonable culinary skills. But in this case, if the recipe is good enough, even if your skills are not good enough, you can make up for them. And reading, learning, and just understanding what you are doing, because it's fully explained and it's very, very well structured just for just copying a couple of commands to verify and to implement the stuff, you can actually become an expert on securing a product. You have the information there. You know the goal, where you are going to go. The information is perfectly structured. And if you want, you can invest and become like an expert into that product thanks to this kind of information, okay? Your hardening work will be as good as your list of security controls. So my goal here is to tell you, don't look to Medium, don't look to YouTube, don't look to tutorials, look to my list of security controls. That it is not mine, of course. It belongs to external companies and organizations. How many lists of security controls do I have? Well, we have the Esquema Nacional de Seguridad, which is the Spanish one, which is, for my point of view, is more textbook-like. So for a teaching point of view, it is not what I'm looking for. I have the security technical implementation guidelines called STICs, like the white driver from Top Gear, okay, which is a list of security controls that applies to 500 plus products that are used for organizations like the US military, Oracle, and pretty heavy stuff, okay? And they are also a collection of things you have to do over any product to make them more secure. Some of them can be automatable, which is something that I will talk in a few minutes, that the application of security controls, the things you have to do to make a product secure, can be automated partially, okay? Disgracefully, automating a STIG application have a cost, so you cannot do that for free, at least with official tools. You have to rely on unofficial tools that you can trust or not trust, but know that people that take these things seriously has an automation tool that take the sticks, the information, and apply most of them automatically, so they can harden operating systems or products with little effort, at least to a respectable level. But my preferred one is the not military control, the CIS benchmarks, the Center of Internet Security Benchmarks. For free, they offer you a PDF with the hardening instructions of popular operating systems, popular products such as Docker, Apache, Tomcat, Internet Information Server, typical browsers, Office products, like 100, okay? 100 different popular products. These PDFs, this list of controls, are created by consensus of 1,800 organizations, big organizations, companies, and governments. Of course, if you pay, you can even have a sizable part of them automated. But I recently discovered, well, in fact, yesterday I discovered that they are offering for free a light version of their automation product, which is called the CISCAT, for free. I still have to test that because I discovered that yesterday, and I think it is in the market like just a couple of weeks. So maybe automated hardening is available as a cost. Now I have to put that into quotation marks, because maybe part of the automation is now possible for free, okay? So if you pay to these people, apart from the free PDFs that you can download, because it's the ones that I use in class, for example, you have the full-fledged CISCAT Pro automation tool, and you can tell the tool, okay, please harden my Windows, and it applies the most controls they have automatically, and Windows become automatically hardened. Of course, you have to be careful, because when you harden a product, you might get rid of the legitimate functionality that must be there. So controls cannot be applied just in a bulk without taking care about what you're doing. But it is a very strong guide and a very strong starting point to make a product more secure. And for me, it's a very strong teaching material because these PDFs are very, very well detailed. Okay, of course, if you know English. And as I insist, part of the security can be automated. I use the international protocol, the SCAP protocol. I explain to my students what is the SCAP protocol. It's just a protocol that just reads XML files that has what they have to do over a product, how to verify them, how to verify what they have to do, and if it is not done, it just apply that. Okay. The problem is that the most famous implementation of the SCAP protocol, the open SCAP, which is free, comes with a couple of controls to apply to certain products, mostly operating systems, that, well, they are good, but they take part from the SIS benchmark, another part from the stick, another part from homemade. They are not as complete and not, from my own point of view, and not as validated as the other sources. But they show the students that you can automate security, okay? Even if you don't have the possibility of automating security, you have a PDF to rely on and become and produce a very strongly hardened Docker, Firefox, Apache, or whatever you want to do, okay? So just a quick points about what I'm trying to transmit here. I try to teach my students that they must not rely on untrusted hardening information sources, so every internet but the things that I say, that they must choose the best source of information for this context. I mean, they must choose the correct security control source. In my case, well, it's only the these ones, but they know that they have military-grade controls in the sticks repository and stuff. I try to transmit then that it is possible to automate part of this kind of security hardening process with the SCAP protocol. And, well, that most of the times, when they are going to work into a company, the company should buy the official tools that automate all of this just with a click, okay? But as we have no budget to invest into the tools, into the paid tools, we just do stuff manually or with third-party scripts that are available for free just to get people the feeling, okay? I insist. Yesterday, I discovered that now the automation tool is partially free, or there is a light version free, so maybe the next year I have to retell this, just taking that into account. But for one data to show you the result of this work. When you install Ubuntu, for example, and you evaluate the security of Ubuntu with a typical tool like Linus, you obtain a score of 54 points, okay? Just a plain installation with nothing else. When you finish applying these controls, even with third-party automation scripts and stuff, you just in 20 minutes investment, you have 91 over 100 points. That is a dramatic increase on the hardening of the Ubuntu that you are operating with this effort. So that is the thing that I try to transmit to them. If you follow automation and if you follow trustable standards, your results will be dramatically good. And of course, better than if you try to follow a manual tutorial or something like this, okay? So my conclusion is you have to treat security problems like an engineer using worldwide recognized standards that are trustable, validated, and maintained. And I promise you that the THEES benchmark standard have every one of these characteristics. And as I said, you first secure the platform, and later on you install things, not in reverse, okay? So is that enough? No, because For securing the operating system, you have to implement a defense in depth strategy. Okay, you have to protect every layer in your infrastructure. So for securing the OS, you follow the corresponding TIS benchmark. For securing the network perimeter, you look if you have the product you are using, if you have a TIS benchmark or a stick belonging to the product, and you follow it. For your application, for the application deployment, the server or stuff, you also look for these kind of products tied to them. And in development, we are trying to just make people know that they have security testing guides, security verification standards, and the next year we are trying to use the students on the school into DevSecOps and to the secure software lifecycle development cycle, okay? The SSDLC. This is the new thing that we are developing for the next year, because we kind of have that, but the structure was not something that we were happy enough. So now we integrated some courses in the third year of the university to develop a coherent strategy in 3 or 4 courses to go into the same direction, and we think that now we will achieve what we want. Okay, and of course, when you deploy, you have also to secure your deployment. And that is when secure Docker take into account, okay? The good part of using these benchmarks is that they have implemented a way of turning your work, your implementation of the security controls, that is just typing things into the terminal. They have like a path to make those things more abstract into these security subcontrols, more abstract, these controls, and implementation groups. And when you go up into the abstraction layer, you find that your actions can be mapped, because they have a mapping table, to things that are present into worldwide security frameworks, like the ISO 27000 series. So if you type something into the terminal, you can put that something into a THIS subcontrol. And that THIS subcontrol can be mapped to an ISO 27000 thing. So your work into the terminal, of course, the amount of work you do into the terminal can be collected and can be transformed into something you can be certified against. So that is like establishing a path between the terminal stuff, the lower level possible, to something you can put into an ISMS. So, I mean, even if I cannot go forward because it is just an undergraduate course and it will be too much, I show them that following this path, you can become very serious and you can develop actual ISMS with the work they are doing right now. Okay, so it's something to motivate them, even if I cannot go further because of time restrictions. And well, we reached Docker. We use Docker for application deployment, obvious. We also use Docker for emulating infrastructures for training, to develop our labs of training, saving tons of resources. If we compare when we use virtual machines, I save a ton of resources. You cannot imagine how I can do this, the whole course with just a virtual machine with 2 GB of RAM and everything works. So for me, it's magic, okay? And of course, one of the things that the people have to know is that, Docker isolates applications, but if you don't treat Docker correctly into the security department, you don't achieve real isolation. And to achieve real isolation, I follow the corresponding THIS benchmark of the Docker. In this case, the THIS benchmark for Docker Community Edition. Okay, and I can say that I am almost at the end of the presentation, because now I will show you why I use this benchmark, and the rest of the presentation is just a brief overview of the things that the THIS benchmark contain, but of course it's just the title and a brief explanation. The PDF is actually very, very thorough and very precise, describing everything that you have to do to lift your Docker into the best security state possible. I mean, everything is in the PDF. Everything is precisely explained. Everything is precisely detailed to tell you what you have to do. And the best thing is that they explain why you have to do. And my Docker course, for example, begin with the foundations and installation, which is typical, security, just after the installation. And when we have a secure Docker, we just try to optimize it, the decreasing the image size and stuff like this, okay? Optimizing the Docker files to deploy faster and stuff like this. But the thing that I want you to show, let me see if Zoom works here. A PDF of the THIS benchmark is composed by thousands, well, not thousands, hundreds of entries that are just like this. It just a number that is for recognition, a title, insert TLS authentication for Docker daemon is configured. Something that tells you if this is scored or not. That means if you do that, you gain a +1 into your security score. If it is not scored, it means that it's just, you should do that, but it is not really critical. You have a classification of the possibility of breaking something that is still working into the machine. A level 1 is not supposed to break anything. A level 2, it tells you be careful, because if you do that, you might break some legitimate functionality you have here. But the magic is description. What is this? Rational. Why do you have to do this? Okay, and this can be, I mean, this is short, and I pick it up to have something that just fits into a single screen. But there are some controls that actually make a very strong effort to explain to you why you have to do this. But the first part is audit. Test if you have this already done. Just copy and paste this command and see if the result is this. If you obtain that it is not already done, to remediate it, you sometimes have to follow simple instructions, or you have another command, you have to copy and paste intro, and you have it done. And well, the rest is just, well, the impact you might have, the classification of these controls, and something that, I mean, for my students is not that important, but imagine that I give you a PDF of 120 things, okay, that is described. It explains to you why you have to do that, and to test if you have it done is just copy paste, and to remediate most of the time is just copy and paste. If you just follow one and the other and the other and the other, at the end, of course, you will have a very strong deployment of Docker. And these guides are verified and validated by 1,800 companies that from time to time updated them and just correct things as the product advances in versions. So I just insist to my students, any product covered by a THIS benchmark is exactly like this. So don't look into other places. Download the PDF because it's free, and follow the instructions, because these instructions cannot be discussed. Can be improved, yes, of course, everything can be improved, but cannot be discussed. You have 1,800 companies, governments, very big companies, experts validating these operations for you. So I cannot best that. Okay, if you don't trust me, trust 1,800 companies worldwide. So now, as I insist, I just have here a brief. This is the THIS benchmark, the section that they have, just with the numbering and the titles, and just to show you how thorough they have. Because, for example, the first time I read that, some things I didn't even know that are part of Docker, and thanks to that, I learned more Docker than I knew on that time. And well, things, for example, that before you harden Docker, you have to harden your host, your operating system. How? Look to the THIS benchmark of your operating system. Of course, Docker is up to date. There are a lot of controls are very trivial, okay? But they are just compiled and structured and organized. And things, for example, that showing you how many files you have to observe for auditing Docker. For example, in this case, I missed a couple of files, and thanks to the PDF, I located files that I was not looking to have an audit of what was happening. And well, it shows you how to configure the Docker daemon, what you have and what you don't have to do to make it more secure. I mean, I will not go into every part because it's part of the PDF. For example, how to to enable TLS authentication, something that I didn't do on that time. And it's very important, but I forget about it. I forgot, my fault. Okay, remote and centralized login, live restore, things, options that Docker, I didn't know that they have, and they are explained here, and why do you have to enable them. The configuration files, where are all the configuration files of the Docker daemon and the strict permissions that they have to have in order to be secure. Look at this, they are all detailed and all precisely done and located. Okay, this is the Docker Community Edition. You have another Docker for the professional version, another Fish benchmark that is, and more things. How to handle your container images and the build file, for example. Very important, this thing. Use trusted base images, which is one of the things that I insist most on my students. Don't download Docker images from anywhere. Try to use official ones. Don't install unnecessary packages, and, well, I mean, rebuild the images you have from time to time to include the latest security patches and stuff like this. That might be trivial, but they are all compiled and specified here. Okay, things about the runtime, how to protect the runtime with ARM or C Linux, depending on your distribution, how to enable kernel capabilities and disable them according to what you have to do to leave the Docker daemon as restricted as you could to avoid isolation problems. Don't run SSH, something with privileged ports, limits on resource usage, because it is not the first time that sometimes in the host become saturated because somebody just misconfigured Docker and your CPU resources are exhausted. And, well, things that maybe you don't know, but they are contained here. So if you read, if you learn, and if you just understand what you are doing, in the end, you will have a very strong Docker, okay? A very, very strong Docker. And of course, some things, for example, the things of this, the container runtime requires you to have a very advanced system knowledge. But if you don't have it, it is all contained here, and it is all explained here. So if you are interested enough, you can know what you are doing. And if you don't, you can do it, even if you don't really understand what is happening behind. But in the end, they tell you that you have to do that to make the strongest Docker that you could, okay? The container runtime is perhaps the most detailed and the most hard thing to understand of everything. And, well, the last section, the section 6, is just to avoid using too many images, to saturate the host with space because you have too many images. And they also have a section to Docker dedicated to Docker Swarm, but I didn't include that here because, well, it's another product and I have a limited amount of space. So, in conclusion, we prioritize Docker security above all else, okay? And I insist this thing or this approach is employed with any other product, okay? Maybe some of you didn't know that all these options to secure Docker exist. I didn't. Now I know, thanks to this kind of information. And I show my students that even if they don't have to deploy a stronghold Docker to pass the subject, not at all, because we are in an undergraduate level, I show them how to go to the end. So if you really have the interest to create a stronghold Docker for some reason, I show you the way, okay? You have to follow this. For passing the course, you, for example, have to implement just a couple of controls that are easy and are easy to understand or quick to deploy, and just a selection, but the procedure is exactly the same. So they know that if they want that, they have to follow the same path, but just invest more time. Of course, they can script a lot of them. And once they have one secure deployment, they can replicate it and make thousands of secure deployments following this kind of approach. And in the end, of course, I show my students that if they want to test if the Docker is secure enough, there are a lot of automated tools that checks the Docker configuration. For example, Claire, Gripe, and Triby in the free part and commercial. Of course, there are also commercial, but in the academia, we cannot use commercial software, not because we don't want, because normally we don't have money for licenses. And of course, I prompt my students to use that kind of tools at the beginning, do a couple of steps, and later on execute the same tool at the end to see the difference and to see that the work matters. And all that investment means that the report that those tools throws at the end make a difference in the quality and the security of the deployment that they have. And well, this the first time that I presented this security first approach was in the CoronaCon, a national conference. The presentation is also free there in the same place that this presentation is, in the ResearchGate. The video of the presentation should be uploaded to the CoronaCon channel, but I don't know why some of the videos were not uploaded yet, maybe in the future. And well, another thing is that if you want to see how crazy I am, I have also unusual approaches to teach security that are also available for free in the form of comics. And of course, this presentation is available here. You have the link into the chat if you are curious about that. And that's all. I really hope I didn't exceed the time I have.
That's okay, Jose. That's okay. Thank you very much. Thank you very much for your presentation. I can tell you, for me, this is amazing talk. Many things that I didn't know. Actually, I don't know if there are questions over there.
I don't see any questions, but actually, I would like to thank Jose, because it was an excellent talk. It addresses points that I wasn't aware. For example, that CIS benchmark, it seems like a pretty useful, let's say, guideline to follow.
You have a lot of them. You just make a quick review about how many products are included there. You might be surprised how many things are there. Cloud deployments, cloud software are there. Amazon, Google Cloud.
Yeah, no, that seems like I was scanning through it while you were talking about it, and it seems like pretty like a exhaustive list. I do have one question, is that maybe we can take it offline. Like, do you have any from the I guess from the automated tools that you described? Like, do you have any recommendations? Have you tested some of them, or which one do you think it's more convenient? I think here on the someone was mentioning also Docker Hub that provides someone by default. But do you have any experience?
Yeah, the Docker Hub has a FIS-hardened image of some products. The problem is that they are developed by third parties, so you have to trust the third parties. I really prefer official ones. So in my well, as I am in an educational environment, of course, if I provide a pre-hardened image, they don't see the process. So I have located a GitHub repository that has the CIS benchmark implemented for Ubuntu 18. It is the Florian. I can look if you are curious. I use that in class, Florian.
Okay, maybe in the interest of time, we can, if you can provide the link or provide information on the chat,
yes,
we can then in the meantime introduce Jesus and because just to not clutter his time. But yeah, thank you very much. It was a very
I had 20 hours for my call, for my talk. It was 20 hours, until tomorrow.
Maybe let's change the scale to minutes.
Look, just to finish today, the implementation of the Ubuntu CIS benchmark PDF is almost complete in this Ansible script, in this GitHub. This is the one that I used in class this year. Only Ubuntu, okay? If you want another product, you have to look further.
Cool.
But you have to trust those people.
Thank you very much, Redondo. Thank you very much. And now we let the stage to Jesus. Jesus, we already introduced you at the beginning. If you want to introduce yourself again, the floor is yours. If you want to share your screen.
I am about to do that when I find where is the PowerPoint, so I can have interesting.
The bottom screen should be in the bottom of this visualization. Controls close to mute
let me-
and stop video.
Exactly, that's why I wanted just to say.
It's on a screen button, a monitor.
Yes, I have it, but I cannot find the presentation.
Oh, it happened to
Itself.
me. Try to open that into another tab of your browser. It happened to me. The PDF was not shown. It's like
What about,
it's like an invisible application.
what about this and then this?
Nice.
Yep,
There
works.
you are. There you are. So the stage is yours, for Jesus. Go ahead.
Okay, so maybe I do this and it's way much better.
Better,
Yes,
yeah.
super cool. Thank you.
Okay,
Perfect.
well, you already introduced me. The first thing is I don't see you anymore, guys. So I don't see your faces and your
That's okay.
grimace or whatever you do. So if you have and the chat, so if something is going on, just please take note of the questions and whatever you want to say, and then let's do it at the end. Sound is okay?
Yes, perfect, Jesus. Let's do that.
Oh, perfect. Okay, so thank you very much for this opportunity. It's going to be. I was watching a little bit what Jose was doing, and it's super. I would like to have that content to review it later because it was very dense. And Jesus Escolar, CEO of EXELERYS. We are 6 years already in business, fighting cybersecurity, cyber intelligence, trying to cover these grounds with a lot of solutions like open source solutions and also commercial solutions. We're going to have a little talk today about the advanced analysis on container security updated for 2021. And I'm going to go from the beginnings to the from the basis to the end. So don't worry if you see things that are for kids on containers. It's just the way things happen. I like to start soft and then go hard on you guys on certain concepts and ideas. So I would like also to thank Cloud Native Asturias for the opportunity to do this talk. Let's start, if it works. So the agenda for today is going to be about these bullet points. So we're going to see the evolution of the infrastructure, what's in for the DevOps, the cloud. No, it's not the CAN. He made an autocorrection. Is the cloud native application landscape, the SRM, so the shared responsibility model, the security modeling for containers, the examples of possible attacks. I'm going to be on the opposite side of what Jose was doing. I will be just talking about the modeling of security and the attacks, and then an example of one particular attack. I'm going to go through it. And then how do we model threat intelligence for containers? And the open source security tools that we have. It's impossible to have all the open source security tools. I've selected a small group of them just to talk about them, and then a step where I talk about what's going to be next, just single slide that tells you what's going to look, what's going to be the future of or the next couple of years, 3 years on cybersecurity for containers. So the first thing is the discussion about the infrastructure. So this slide is very classical. It tells you that we started all with physical servers, with all type of different operating systems. Then we jumped into the virtual environments and the virtualization. Then we jumped into the cloud, which was a fantastic evolution for us, very expensive, nearly impossible to use at some point. And then we jumped into containers. That's where we actually stopped. There is another talk that I do about serverless, but that's completely different. That's that's for another event. The goal of the containers, obviously, is to move for what we see. And I know that you know that, but the thing is, at some point, you have to have a vision on why this was made and what was the purpose. The vision was that as we were creating virtual machines in order to consolidate resources and compact everything into a single place to be able to scale, to have better manageability, orchestration, automation, consolidation, etc. But that was not enough, because every time you wanted to spin a project that was very complex and required a lot of resources, you had to create too many of them. Every time somebody was asking for a SQL server or for a MySQL or for a Postgres cluster, the problems arise about, okay, we need to build this, it's going to take 8 weeks, etc. Even today in my actual projects, when I ask for a single virtual machine, people are coming back to me telling me, okay, you know what, you need to wait 2 months or 3 months until we give you the VM, because it's not as easy as a command line. And containers, with the logic of the container engine, put everything together to give us the ability to just run what we need, the application, and not the resources that the application is actually using. And that part, it was a fantastic acceleration. We can spin 100 of them on demand, and it cost us what? 2 minutes, 1 minute, the approval of somebody sitting in a desk beside. But it comes with a lot of problems in the backend. And the problems are the fact that everything is shared. And I want to talk about this concept of DevOps and shared responsibility model. So like the movie, The Usual Suspects, where what's in for, what was the name of the actor? It was Kevin Spacey, but the name of the character that he was doing, he was says, what's in for me, when he was being investigated by the police. What's in for the DevOps? So DevOps exists a long time ago, before we had even containers. We had a beginning of our organization that was mixing the developers with the operations and the infrastructure. And at that point, the logic was to understand what all of this is going to mean for the DevOps team. The first thing is to understand that the DevOps are coming from an old concept versus a new concept. The old concept was that the people were actually developing in groups, in separated entities, and the operations were in another entity building all the infrastructure for the people to develop, the pipelines for development, etc. But at some point, everything started to be consolidated, and they were all together trying to put some kind of orchestration in the process. It's the functional side of the DevOps, not the operational side. The old model of developing about having resources, virtual machines, physical servers, was not efficient, and it was totally dysfunctional to answer the requirements and the needs that were happening at that time. It was totally ineffective. Then everybody understood that it came from a non-organic growing model, where everything was built for the needs at the point and not the needs of the business. That was actually the old development. And it went from being monolithic to multi-layered, multi-dimensional, many different layers of development, totally in parallel, multi-dimensional, many different types of platforms, supports, coding, with a lot of different disciplines that all integrated the development at the end, all based on what we today understand as CI/CDs, so the pipelines, and also the containers and the orchestration behind the containers. It was born through non-procedural security-oriented teams. These teams were not ready to provide a structure that was standardized to implement security into it. I agree that people say that they implement security today in containers, but in reality, what they do is they apply the best of the best practices. But they don't really put today the full scope of security. You're going to see that in a few slides. As I said, it's made by developers for the developers. It's not made by developers or by the security team for the developers and for the organization. I don't want to segment people. I want people to stay all together. We are part of the same team. We're not part of separated teams. When you look at the DevOps tool stack, you see that this is only a picture of what we can see. Is only a part of the whole process. And already you have hundreds of elements to play with. A lot of the people put a lot of these elements into place, but it could be worse. You can go to the Cloud Native landscape, and then you have this picture. And when you have this picture, you're like, I cannot even read the characters there. I cannot even see the names. Even if you zoom, it's going to be a problem to follow it. So how can we secure all of the things that we see here? Can we actually secure them? Can we actually use the tools there? We need to understand what's going to be important for us based on the different processes on how are we going to model security for our containerized environments. One thing that happens that I like to talk about all the time is the fact that who owns the security? Who is responsible? When you look into it, you think, well, I think that if I'm using a platform that is not mine, the security is not my responsibility. On the other side, whoever owns the platform will tell you that's your responsibility 100%. So it's going to be like throwing rocks at each other. The reality is based on a single model. You have the shared responsibility model. You see what is on the foundational services. That is what is provided to you. That is where you're going to put your elements. That's what you're going to consume as somebody who buys the resources. And then whatever is on top is what you're responsible for. You're responsible for adding all the security in all of the blue, dark blue, or dark violet areas. That is what you are actually consuming and creating, and that's what you actually need to secure. Is that point clear to everybody? This is the part that is the most important, this element, to understand that you have to put the security there. The conditions, and I always put the COVID-19 challenges, because for me, in the past, it was only 3 months that we thought that we were going to be in confinement, that it jumped into 6 months, and we end up being, what, 1.5 years. All of that has changed all the actual understanding of the security, especially because it was an explosion of what we call business continuity processes and disaster recovery plans, leaving security in the back and leaving all the budgets of security for the end. We needed to secure whatever was going to happen, but we needed to secure the workforce and our business to be continuously delivering the business. We have elements like the infrastructure completely changing, the apps being developed and deployed every day, the threats. We always forget that what we're thinking about security, what the understanding we have is that the security is something that I put into place, I forget, I go home, and I don't talk about it anymore. It's false. The threats are continually evolving, and they are becoming more sophisticated, and we need more people today understanding them to be able to actually fight them, which means that we have to jump into higher and more deep, complex threat protection and auditing. We need to actually monitor the performance of our resources and our clouds and our even on-premises resources. And in fact, we need to simplify the ability to deliver security. We need to automate, orchestrate, and deliver security in a way that is not a pain or is not against the business model. Remember, I am a very business-focused person. I always think that business comes first, the show must go on, and we need to put security in place at the same time that we are aligned with the business. The modeling for containers when it comes to security must be based on the understanding of how and what we need to actually look into. So when we look into containers, we need to understand where, what, how, and when do I need to secure them? In which phase or point of the whole process? So is it the host? Is it going to be the applications? Is it going to be the images I'm using? Is it going to be the EIM airbag? Is it going to be the framework I'm using? Is it going to be the users that are going to be consuming it? Is it going to be the consumer? Sorry, the users are going to be having? Is it going to be the consumers at the end of the sales process and the application process? At the end of the people, the B2C, the C side. Is it all of them? Is none of them? Do I need to forget about that? This question is very important, and it's also a slide deck. I have a part where I take like every question and every step with a lot of Q&A that helps understanding what is going to be the questions that you need to ask and the answers that you should be expecting. When it comes to the paradigm of containers in security, they are running all of them on an OS. It's not magic. There is no magic money, there is no magic containers, everything runs on an operating system. So that means that we're gonna have a lot of security issues based on that operating system. And also they're sharing libraries, which means that I'm gonna have a lot of problems with the libraries that are running there. Plus there is the code, where I need to also look into how the code is built to be committed, to be compiled, and then to deliver my applications inside the containers. We have a lot of responsibilities that are beyond what we understand today on the virtualization landscape, known as our traditional landscape. when we create resources. This is no more about VMs, this is no more about the logic. We need to look into the fact that there are multiple users, multiple tenants. We're going to have packaging problems. We're going to have vulnerabilities that we're going to be unable to see. We're going to have problems of patching, incompatibilities. We need to find out how we're going to make people accountable for, and accountability for the actual security issues. How we're going to see the accessibility and monitor it. How we're going to create the proper firewalling and the traffic management, role-based access control, EIM, and so on and so on and so on. And if we don't put the right resources into place, this will be an impossible task to follow. On top of that, sorry guys, I'm like this, I always have issues in the talks, but it's good. The second step is, sorry about that, unexpected. Somebody's going to take care about that. So the second step about the security paradigm on containers will be that we do have a problem with the coding of the runtime execution. We have the problems with the RASP. We have the problems with the APIs. We need to also look into what are the issues within the CIs and the CD. And in the past, we were talking monolithic. My devs, my areas, my region, I manage them, I whip them when I need to, I keep them safe. But now I have probably 5 teams, they deliver stuff, and we don't actually control in reality what is actually happening. And that is a big problem because it goes from monolithic to modular. When we're building or on top containerized apps, and eventually they become microservices, the security changes because all security solutions, they don't innovate at the same speed. The amount of speed and coding is fast. We are looking today at solutions that are able to process, some of them are able to process a few 100,000 lines of code before the committing. Others are looking into 7.5 million lines of code. This is nearly real time, but the people are coding a lot. They're coding enormous quantities of information. The techniques also have changed. And that is something I want to talk about when it comes to the coding of the malware. The controls that we had in the past are not applicable for today, which means that the cost, the complexity, the processes that exist into place are going to be broken. The result is that we have a lot of applications that are delivered very fast, and they are producing a lot of issues that we don't have, that we didn't have in the past when delivered to the market. We call that fail fast, fail often, fix fast, fail often. So that's the big problem because you're actually doing a lot of problems, creating a lot of problems and fixing them later. We also have the problem of the containerized apps not being controlled, and the adoption of containers going very fast and giving no ability to actually being managed properly. And I'm saying that about the environments where we are not actually having a proper infrastructure in place to have the whole controls. That's one part. Now, this slide, I think, is worth, for the people who want to have a quick look, it's worth a lot of gold because it tells you exactly using Docker architecture, everything that you should actually be setting in place for security. So when it comes, for example, to the client with the APIs, we should be looking to API security, authentication, airbag. When it comes to the host, at the level of the host, you should be looking into IPS, firewalling, next generation firewalling, vulnerabilities analysis, integrity monitoring, and dynamic checks of the runtime. When it comes to the host also, you need to look in, I was talking about the containers. When you look into the host, you need to look into anti-malware, you need to look into the URL reputation, web reputation, and web inspection. You need to look also into the IPS, firewall. This is 2 different IPSs and firewall. They work in a different way. They don't look into the same things. The integrity checks and also the log inspection, which actually allows us to look into the logs of the host and report if there is logs that may be matching a potential anomaly into the system that leads eventually to a potential threat. Basically, the log inspection there looks into specific events, into the whole system logs, the host logs, to say this combination of logs implies automatically that there is a potential threat in action. Then you look into credentials, access control, IP reputation to prevent who can access and when. When it comes to the images, the vulnerabilities into the images, the integrity checks into the images, and the static checks to make sure that there is nothing vulnerable or malicious into it. And when it comes to registry, obviously image integrity and image immutability. We don't want anything to be modified. One of the things about this picture is that it needs to be on 100% immutable. Example of attacks that we have, we can look into, for example, the list of the most complex one. We have the fork bombs. So that means that we can actually spin an unlimited amount of processes into a container, and means that leads to a very, very bad situation. We can also have unwanted communication between unlinked containers, containers that are not supposed to talk to each other. They are passing communication across them. Then you can UTP, which is basically unauthorized private traffic. There is a definition for that in our threat model, which is the lateral movement. In an APT, this is what we call the phase 4, step 4. In an APT, which is an advanced persistent threat, which is part of an attack that is targeting an organization with an declared and clear intention to obtain some potential footprint to lead to a further exploitation of the resources and exfiltration of the data. Lateral movement is a way to find out better resources to escalate later to where the sensible data and the critical data of the organization is. Rogue images that should not be there, spoofed by probably these malicious actors. Orphaned images. Do I want to have orphaned images there that belong to nowhere and they are just residing there and being left there for people later to be exploited? Rogue processes inside the containers. Do I have to look into all the processes, see which processes are legitimate and which ones do not need to be there? Rogue libraries, people putting libraries there that can be later on used in those particular containers. Volume mounts that are persistent, so allows them to actually put additional malicious script and malware that will be then used to exploit the resources of the company and then escalate, do lateral movement, etc. Cryptojacking containers host. Well, you have a fantastic infrastructure. Why do I not use it for crypto mining? Persistent malware. So that's the full ATP in place in your organization, which means that you have to detect the CNC or C2C, which is command and control communications. Fileless attacks, which is actually something that happens in the next proof of concept that I have to present you, which eventually at one point we will do something together. There will be a lab about that. So you ready for the example? You're hearing me, no? Everything is okay. I don't see you. Everything is fine?
All right. Yeah.
Good. So here we have an example, which is the Kinsing malware attack 3. The Kinsing malware was an attack that was detected by Aqua. Could have been anybody. And this particular attack, basically, it was based on the detection of an open API port in a Docker daemon, which then launched automatically an Ubuntu container. The Ubuntu container automatically downloaded from the IP address that appears there the particular shell script, okay? That shell script was then executed, and by executing that shell script, it created a contact for persistence, so it established proper footprint into the organization, and then contacted the IP address from the Kinsing to download the malware, which eventually downloaded the piece of malware with a hash that you see there, and as you can see, Clamp detected it as an Unix malware agent with the string detection. And the Kinsing malware was actually doing a lateral movement download script that was used to spread itself across whatever resources were available. What was actually the real purpose of that particular script? It was to scan every single resources in that particular host to see how it was going to scale across the different machines and containers. What was left open? What was vulnerable? And starting there, it launched a crypto miner with a command and control IP to call back home. It had a couple of CNC command and control IPs to communicate, and then it used the lateral movement to find out credentials, and then using the keys and the credentials to jump over. very, very nasty stuff and very bad. Now, talking about the modeling of threat intelligence for containers, elements that we need to think into is the MITRE. And MITRE for me is one of the biggest references that we can have, because it gives us the ability to map an example. MITRE has a huge amount of threat techniques and procedures that we can actually map whatever attack that we see here on what it looks in the MITRE. You can go to attack.mitre.org. It's a basic reference. Everybody needs in security needs to go to this website and read, learn, nearly memorize that, because the next time you want to talk about what happened in security with directors, executives, CISOs, CIOs, anybody, CTOs, explain them the problems of what happened or what could happen. If you put this slide, they will understand that it goes step by step. As you can see, lateral movement is reflected here as step 1, 2, 3, 4, 5, 6, 7. It's different from the APT. MITRE is not mapping APTs in the same way. It's just mapping their model, their framework with what happened in the previous one. And you can see that everything was exposed there. When it comes to pipelines that end up creating code, generating code that's going to be committed, and then is going to build those applications that's going to be then pushed into my host and then run as containers, the elements I need to look in are these 7 points. The scanning of my integrations and my code, the registry scanning, the admission control, what can be actually pushed. I decide what can be pushed. I cannot just push anything. I need to have a proper admission control. That is on the pipeline scanning. Then in the runtime protection, that's where I look for vulnerabilities on the runtime of the containers and malware. I look into the platform. It could be, I say Docker, but it could be anything else. And Kubernetes could also be anything else. I just put some example there. The container host itself, never forget the host. The host is as bad in terms of security as Docker itself or Kubernetes. And then the intrinsic protection for containers, which is inside the containers themselves, and also for serverless, if you're ever using any serverless communications within the code that you publish in there. How do you mitigate them? Looking for vulnerabilities, shielding and identifying and listing the vulnerabilities, shielding the vulnerabilities, looking for malware, for signature or machine learning, doing continuous scanning. One thing about malware, I would like also to express that sandboxing is very important. Taking the malware, taking the file, detonating it into a controlled environment and looking into the results. That way, you're going to be able to say this piece of software or this particular code there, particular executable there is a bad one. Looking into the continuous scanning, or whatever's happening in the container, looking into the historical data, you need to do what's called retro feedback. So that has a specific technical word, it's called retro scan. You have all the historical data, and what you do is you go back on time. Once you have the new threat intelligence loaded, you look back to see if anything that happened there was a bad activity, an anomalous activity. You need to check for the immutability, to allow to see that it has no change, and then you need everything to be totally frictionless and automated. Example of open source security tools, little example that we can use for containers. We can have, for example, the Vector, the open source CIS Kubernetes benchmark that was explained by Jose previously. The CIS is fantastic, free tool that you can use to check against the CIS. You can look into Aqua with KubeBench. That's exactly the same thing. It's just a different tool. It looks into all the CIS and then identifies what are the actual statuses, the ones that fail and the ones that pass, or the ones that give you just basically informational status. You can use Claire, for example, to do static analysis for vulnerabilities on AppC or Docker. Okay, so it's basically static. They don't need to be launched, and it's good when it's static, but we also need runtime. Anchor, for example, Now it just looks into the validation of the container itself, to inspect it, to see the analysis, and then to create your policies and say whether the policies I prepare with Anchor are allowing me to evaluate if it's going to pass or not. What we see there is a gate that allows you to pass in only one direction. If you go on that direction and you are okay with the policies, they will pass. If not, it's over. And SysDig, which I love, for example, as a solution, which gives me the ability to do everything that I can. It will actually look into the zero-day threats, it will look into the vulnerabilities, it will look into the execution, it will make also compliance. I can put a lot of security parameters there to define compliance, what can be executed, how, from where, what content, etc. And eventually provide me with all of this cycle of validation. And obviously, notary, you know, which is basically to make sure that there is no forgery or tampering, okay, when you're actually publishing images. You need to ensure that whatever you are approving in your organization is trusted, signed, and basically it's the same thing as validating in your day-to-day Linux environment where you download a push of a update, you know it's digitally signed, it's valid. This is exactly the same thing. But this service, for example, is also included in other solutions. So this is just one that I put as an example. What's next? Well, at the moment, we have a lot of elements to talk about. The first thing is that this environment, it changes all the time. So whatever I said today, it has no validity on 2022 because things will change, the attacks will completely change, and my slides will have to change. Hosts can be infected, images can be infected, source code can be infected, libraries can be infected, the applications can be modified for specific malicious purposes. The pipeline of development and publishing of these containers can be compromised at many different stages. You need to put all the security in all of these stages. And there are all the time, every day, articles and papers about how containers can be vulnerated with malware and how you can prove in 2 seconds that I can drop malware inside your containers. So what you need to actually is to think about the future. Get my vision, get the vision for the next 10 years, probably even for the next 20 years. Think about how you're going to bring anti-malware or anti-malicious activities, which is going to be the future, that are not signature-based. How you're going to look into the behavior analysis and monitoring, including the behavior with machine learning and artificial intelligence. The behavior over the time creates a baseline. The baseline needs to be used to create what is going to be the security of the future. I know what's going on. I can see it now. If it deviates from it, it's bad. Vulnerabilities and exploit shielding, and obviously sandboxing, because it's not enough for the vulnerabilities. Sometimes we don't see them, we are unable to detect them. The malware is very good, it's too good today. I get cases of customers, huge customers with ransomware all the time, and believe me, they had the latest version of the security protections for the cloud, for the endpoint, but still they get attacked by a ransomware. You need to be 100% proactive. So invest now in container security, and you will later do not regret it. That's it. Any questions? And if there are questions, thank you very much for the presentation. As you see, I was quite effective and fast to avoid having to stay long with you. And I will just leave it now to the people.
Yep. Thank you, Jesus. Thanks for this very interesting.
And that allows me to drink my beer and say cheers to all of the attendees. And thank you very much.
Cheers to you.
Cheers. Yeah, we have a question from Daniel Gonzalez. Thanks for your presentation, Jesus. Are you going to upload the slides somewhere after the presentation?
Yes,
That's the first
absolutely.
question.
I will put it. Unfortunately, I need to put it on PDF, just because. But if somebody needs one of the diagrams, as far as it respects that is being, it says where is the source coming from, I'm okay. If somebody needs a diagram for a presentation whatsoever, it's okay. Yeah.
Okay. And then, yeah, he's mentioning that there's a lot of information to ingest and to read and to digest. So that's why he has I guess he's asking for the presentation. Also, any recommendations on Kubernetes daemon live continuous security tools?
So
I guess he asked.
This is the problem. So is it going to pay or not? This is the thing. Free today, continuous. Let me tell you something. Continuous protection, and free in the container environment is not possible.
Okay, noted.
It's like this. It's not possible. Why? Because people give you tools and give you solutions, open source, even the people who build open source sources. But give me 1 second. Give me just 1 second.
Yep.
Sorry, I'm back. So so the problem is that free and continuous is impossible. So people give you tools that are actually open source. They give you scripts. They give you the ability for you to code them, to build your own automation, but they don't give you the automated tools with everything in a table and all put into a box and say, okay, you're going to deploy that is OSS and automatically is deployed as flat. It's impossible. The money maker today for these solutions is the sources of the threat intelligence, the quality of the threat intelligence, the fact that they want to give you the actual threat intelligence up to date with the 0 days, and the automation orchestration you pay for them. So I can find out what I can do for Daniel Gonzalez is write me an email, okay? Automatically, I'm going to put my email here.
Yep, sounds good.
And he can write me an email, okay? And he can actually straightforward tell me, okay, I have this, well, how can I automate it? No worries, I can figure out the best that has been done in open source without paying, but usually the players, they want you to pay. That's where they make the money. It's they give you this. It costs a lot of money to build these solutions when you want to have them 0-day threats, automation, orchestration. One thing that you have to pay a lot of money for, integration. This is the real part where it's hard.
Yeah. There is another question. Yeah, there is another question from actually the other speaker, from Jose. Is Notary free to test for academic paper?
Absolutely, it's free. It's 100% free.
Okay.
Everything that I show there is free. It's in fact, what I can do is I can write me an email, Jose, write me an email and ask me for the full list of full open source security solutions. In fact, it would be very nice to send it to everybody.
Thank you.
Sure, if you can provide that, we can put it in the social media, in our accounts, and we can share with the people.
This is massive. But then
that will be great.
Don't expect that to be like Magic Mike, because it's not going to be it. And you're gonna get like you get what you get for. You pay nothing, you get whatever they can deliver.
Yeah. Well, makes sense. Thank you very much. Thanks. I don't have. Oh, there may be another one actually.
Yeah.
It's from Ismail. What about OPA, Open Policy Agents? I saw some mention for admission stuff in Kubernetes, but no OPA was mentioned.
Yes, because probably what happens is that I forgot to put it. But that's because I was not oriented to Kubernetes exclusively. But there is a plan also to have a talk that is purely oriented to Kubernetes. So basically, instead of talking about Docker or whatsoever, we forget about the container engine, and we move into, okay, we assume that you've done everything right for the container engine. We don't think about that. Now let's talk about orchestration and how I'm going to manage, my pods. So now we talk about Kubernetes security. And you're totally right. When it comes to Kubernetes security, there are going to be extra slides about what needs to be done there, which is, yes, in the case, the policy admission.
Okay, great. Thanks for answering that. I don't think there are any other questions, so I think we can, yeah, it's back to you, Marcos.
Yes, so yes, I will share my screen now, just to put the ribbon to this. So what I can say, thank you, everybody, both the speakers. I think it was great talks from both of you, talking about security, talking about Docker, which is nowadays is crucial because almost everything is in the cloud, so it makes a lot of sense. A lot of things to take to pay the attention as far as I saw. So really interesting. And of course, thank you everybody, all the attendees that we have in this session. Just in case you want to follow up, Angela and I myself, we will be on Twitch. In case you want to join us, we will just make a post-match talk, very brief. And that's all, I would say. Again, thank you very much, everybody. Be safe, and see you next time.
Thanks, everybody. Have a good
Ciao.
rest of the day. Bye.
Thank you very much.